Hello everyone and welcome to today's webinar, Maximising the Benefits of Digitalisation in ATM. Before we get started, I would like to go over a few items so you know how to participate in today's event. You may have joined the presentation listening using your computer speaker system by default. If you'd prefer to join over the telephone, just select phone call in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. It is my pleasure to introduce you to our moderator today, Eduardo Garcia, Manager for the European ATM Coordination and Safety with Canso. Eduardo coordinates and advocates Canso Europe positions on technical, operations and safety matters. He received the CESAR Distinguished Service Award for sustained outstanding performance in the HALA, the higher automation levels in ATM, research network by the CESAR Scientific Committee. So, Eduardo, I hand the floor over to you.
Many thanks, Helen. And hello, everyone from Brussels. A warm welcome to this virtual conference co-organized by Canso and Indra on maximizing the benefits of digitalization in air traffic management. The digital transformation of aviation is a pathway to build a smarter and more sustainable aviation system for the generations to come. However, the dramatic reduction in flight has caused a significant drop in revenue for all ANSPs around the world. A recent ICAO economic impact analysis has shown that all regions of the world experience a massive reduction in revenue, which directly correlates to ANSP investment capabilities. We should not allow this crisis to stop innovation in aviation. We must find ways to build in resilience, plan for the future, and ensure the air traffic management industry is ready to handle future increases in traffic in a safe, efficient, and sustainable way. So it is essential for ANSPs to invest wisely. The aviation industry is being transformed by digitalization with increasing automation and exchange of data among all parts of the aviation value chains. But this is only the start. Maximizing the potential of digitalization is key to the future success of aviation, and it will play an increasingly important role in the future of the aviation industry. Digitalization and virtualization are activities that ANSPs have committed to for quite some years now, and form part of the Canso Europe 2035 vision, outlining the importance of including such technologies and solutions for the future of air traffic management. Digitalization will enable improved performance through the modernization of the information exchange infrastructure and through new concepts for control centers and tower operations based on the use of virtualization and remote provision technologies. Many ANSPs already have deployed these technologies or are engaged in the implementation projects. Improved data sharing, facilitated by swing concept and service-oriented architecture, will also boost innovation and will ultimately lead to even further enhanced performance. In the meantime, the digital transformation of ATM will also contribute to facilitate the safe integration of all new urban vehicles, including drones, supersonic aircraft, space vehicles, and more. But now it is my pleasure to take you through a very interesting session. We have structured this webinar in two parts. In the first part, our speakers from Avinor and Navigation Services, Indra, and Enaire will present their visions and projects on digital and remote tower systems, virtualization, cybersecurity, voice IP solutions, and digital node and swim. In the second part, we will have a Q&A session with all the speakers. So I encourage you to send your questions as explained by Helen. Please use this chat functionality. And if possible, also please indicate to which speaker you would like to address your question. So let's start now with the first presentation on integrating digital and remote tower systems. Our first speaker is Torbjørn Henriksen. Torbjørn started his career as an ATCO back in 1983 and worked for 17 years as an operational controller. After his operational career, he held several positions involving training and business area management with Evinor ENS. He is currently working as Operational Solution Manager in the Remote Tower program of Evinor Navigation Services. So please, Torben.
Thank you very much, Eduardo, and thank you for joining this webinar to all of you. I'm going to present our roadmap towards a digital air traffic management with our perspective and with the background from our remote tower program. And this picture we see here is actually from our new remote tower center located in Bodø in Norway, designed to house 15 airports altogether. And we plan to move in here with our operations for 4 airports in during Q3 of this year, and expanding that number of airports to 10 towards the end of 2021. So the next slide, please. Well, digital ATM, what about the tower is the introductory question. And this picture, I guess many will recognize the old tower with which in the outset was a very analog thing. But when introducing new systems, we have got a multitude of screens and input devices and so on. And when we're talking about remote towers and achieving the goals that we would like to achieve, we couldn't be able to multiply that picture we see up on the left here by 10 or 15. So we need to get somewhere else. We need to get to the picture below here. And then the question is, why and how? And a little word of caution here, because we do not have all the answers to how, at least. We have some perspectives on why, seen from our daily operations. Next slide, please. Our goals with the remote tower program involving the digitalization of the tower operation is to reduce our future investments. In addition to that, we have a target as all NSPs to reduce the operational cost. How can we make the operation more cost effective? And I also have to underline the fact that the airports that we are currently talking about do not have a capacity issue as such, but their availability is critical to the communities that they serve. So being able to deliver a flexible service to our airport customers in times of opening hours, and also availability for ambulance flights, search and rescue missions, or offshore helicopter operations is very important. The enablers to get there, as we have a more digital technology available, is that we can reduce our investment in building infrastructure. We see an opportunity here to standardize technology and systems, and by doing that we can also standardize our operations and our service to the airports and the airlines. By centralizing our service, we can achieve a more flexible rostering and a more efficient operation. And ultimately, we aim to be able to deliver services to multiple airports from a single working position. Next slide, please. When we look at airport operations and airport control towers, we face a set of traditional constraints. We see a multitude of legacy systems installed in the towers and at the airports over time, and they are not necessarily compatible with each other. So we experience quite a number of airport-specific differences. Some of them are justifiable, other we could be able to remove. But we also see that we have tower unit specific differences, and of course not every tower operations can be exactly the same, but we can still overcome some hurdles by standardization and looking into a more uniform way of delivering the services. And since we have a multitude of legacy systems, we also see that we have a high degree of variations in different interfaces between systems and the human-machine interface. And all of this requires specific training, specific approaches to the individual towers. So these are constraints that in a centralized operation, we need to try and get around them. Next slide, please. How could we remove these traditional constraints that we see when we look at several airports and several tower units? In our center, we have installed 16 working positions to serve the 15 airports that we plan to put in there in the end. All of these 16 working positions have exactly the same basic layout. We are removing the old legacy systems, and we are still handling airport differences, which are airport specific, different lighting systems, different set of navigation aids, or different procedures for the unit. But we do this with the same basic human-machine interface for every airport. We also introduce electronic flight strips, and we introduce a surveillance capability, and we have the same system for all airports independent of their local infrastructure. And this makes it possible to be flexible because all working positions in the center facilitate all the roles that we put in there. This will give us an advantage in single operation, and I'll get a little bit back to that in a few minutes, but ultimately that we can operate 2 or 3 airports in a multiple operation from one single working positions. Next slide, please. In the system that we deploy, we have a set of functional scopes. We have electronic flight strips, as mentioned. We have a traffic situation display, providing a picture of the surveillance data to the controller. We have an interface to operate aerodrome lighting systems, to monitor navigational aids, power supply, and other airport critical systems. We have weather sensors coupled with automatic weather observation systems and ATIS. And we have the interface to operate the camera systems on the airport. Different display angles, zoom functions, use of infrared, things like that. And we have an alarm system, both to provide warnings and alerts from the aerodrome itself, but also to provide alerts and alarms related to the operation and the technical infrastructure at the center. All of these functional scopes are included in an integrated workstation with one single workspace for all of these functions. We have kept the voice communication system as a separate system, and bearing in mind the criticality of having voice communication available at all times. Next slide, please. What advantages can we achieve by having this integrated solution and standardized solution? Well, first of all, one important factor to achieve the cost benefits that we are aiming to achieve is that the individuals working in the center, in fact, can have multiple aerodrome endorsements. because that gives us more flexibility, even if we operate single airports. And bearing in mind the traffic load that we have at these airports that we bring into the center, at least in the first phase of the program, we can see that also when operating in single mode, we can achieve more flexibility in rostering by having multiple aerodrome endorsements for each individual in the center. But that's also, of course, an enabler for a multiple mode of operation. Through the standardization and the integration, we can operate with one unit training plan for the whole center. Of course, there are local differences, but we try to keep them as few as possible. We have the same tools and the same basic human-machine interface for all aerodromes. So that means that we can deliver a single course for the system in the beginning and just add on the local differences as required for each and every individual airports. And also in this program, we strive to implement as far as possible common unit operational procedures, getting rid of any differences towards individual airports which are actually not justifiable. So by doing this standardization, we can achieve more efficient training, we can reduce training time, and we can also improve flexibility in the service provision to the airports, both in single mode and ultimately in a multiple mode of operation. Next slide, please. And then a little look finally into the future. What further digital improvements can be brought forward to us to help us along the way? Well, we see that surveillance data is becoming more and more available at a lower cost than previously with the traditional radar infrastructure. We are already using ADS-B in our airspace, and we have introduced wide area multilateration and local area multilateration. And the question is, could we have ground surveillance at smaller airport at a reasonable cost? Would bring us safety benefits and perhaps also operational efficiency benefits in the future. Data link communication is another opportunity which we can use in the remote service provision. We can have more automation, like automatic transmission of METAR and automatic ATIS, and we can also introduce safety nets at airport based, for instance, on the surveillance capability that we could have in the future, which is currently not available on smaller airport. And finally, we have heard about the artificial intelligence coming into the ATM industry. Sounds a little bit scary to a man of my age, maybe. And I read the council paper on artificial intelligence, and I must admit I had to read it a couple of times more to understand everything in there. But the remote tower and the digital tower technology is specifically mentioned in this, where the AI technology can enable the system to identify objects, aircraft, vehicles, personnel, or wildlife maybe, and in addition to that, perhaps be able to detect situations that can be potentially dangerous and recognize those situations. So it's a very interesting and intriguing future that we are facing. But we see that the digital technology and the integration into a single workspace gives us and puts us in a position to actually improve our service quality and improve our cost efficiency in the operation. And with that, I think I'll close my presentation. Thank you very much for your attention.
Many thanks, Torbjörn. Many thanks for a very interesting and comprehensive presentation on the Avinor's activities related to digitalization. I look forward to discuss the Council position on artificial intelligence with you. Just a reminder to all of you that it is fully available to download in the Council website. It is a very interesting document that has been published by Council just a few weeks ago. But now next, let's move to our second speaker, David Roberts. So David is Indra's product advisor for tower systems. He has more than 40 years of experience from the industry and has worked closely with many NSPs and represents Indra on Eurocai's Working Group 41. So please, David, floor is yours.
Thank you very much, Eduardo, and good afternoon, everyone. Can I start by asking for the next slide, please? Torbjörn gave a very good presentation on the remote tower system and the integration which has been done for that, and showed this picture of the different displays and HMIs at one of the Norwegian towers. What I would like to do is to share with you a little bit of some of the history of what we've been doing on integration for manned towers or conventional towers, not only for the remote ones. But it bases itself on a lot of the work which we have been doing up through the years on our surveillance data processing systems, electronic flight strip systems, work together with Avinor and for the CSAR research programs. Next slide, please. Initially, we saw that there were a lot of towers where we were going to deliver systems where you had a plethora of different displays, different keyboards, mice, and they were very, very constricted in their space. There was not very much room for us to be able to deliver a number of our systems. Nowadays, of course, with remote towers, we're looking at no towers at all. And if people do build towers, they tend to be rather small in space. Another problem we had was that we saw controllers were complaining about information being in the wrong place. We had to put displays up in the ceilings, or some of the information they wanted was actually located quite far away from where they were sitting. And you also had the problems with the different HMIs between the different systems. Lastly, costs on installing such systems, especially with a lot of modern technology, although computer costs in general have gone down, costs on other technology which is used in the towers has gone up by an incredible amount. Next, please. Next slide, please. Sorry, yeah. I would say that integrating tower display systems is nothing new. We started in the early 2000s by doing this at a number of sites in the United Kingdom. We delivered tower displays and surface movement displays to, amongst other airports, Gatwick and Stansted. Very early on, this was done by integrating the actual server and processing so that we reduced the amount of interfaces, we reduced the training which was needed. But what was up in the control tower was still two separate displays. It did, however, save quite a bit on maintenance and configuration costs and room in the equipment rooms. The picture you see here is from London Heathrow prior to us having done an upgrade there. And you can actually see that you've got both a surface movement system and an ATM system as two individual displays along with all the other equipment which is needed up in the tower. Can I have the next slide, please? Heathrow actually had four different systems. They had an ATM system for the tower and a surface movement system for their control tower. And then they also had the virtual control facility, which is located in a totally different place than on the airport, where they also had two similar systems. The last upgrade which we did for Heathrow was actually combining these. So now they only have two systems. And the result is a widescreen display in the control tower. So we've minimized and taken out half of the displays they had up there provided by us and given them one very large display, which you see a screenshot of here. Here you see the ASMGCS display on the left and the air traffic monitor or ATM display on the right, which, depending upon the operation, can be refigured and the windows moved. However, with the new software we're developing and delivering, and because the work, as I said, done with Avinor and within CSAR, we can extend this by adding new functionality and integrating further systems on it. If I could have the next slide, please. What we now see is a number of airports around the place where they want to integrate this additional functionality. This includes monitoring of nav aids, so what is shown in the example to the bottom right here. The monitoring of MET information and display of MET information for controllers, which is shown to the top left. AGL systems and control of the lighting at the airport, shown on the bottom left. And any old information such as AIS information, etc., which is shown on the top right. This is where we see the future going and where we see a lot of airports now wanting to do this to remove some of the other equipment and displays and harmonize the HMI within the control tower. Next slide, please. And with that, I think I will keep my presentation very short and brief and say thank you very much for your attention.
Many thanks, David. A short reminder to the audience, we will have the Q&A session after the 4 presentations, but please, you can start sending your questions right now. So please use this chat functionality to send your questions to the speakers. So let's move now to our second presentation on virtualization in air traffic management and cybersecurity. Our third speaker is Jose Maria Caro. Jose Maria is the ITech system architect for air traffic management and air traffic control systems at Indra Systems. He is a telecommunication engineer with over 15 years of experience in air traffic management systems. He has been involved in several areas such as testing, system engineering, architecture, and cybersecurity. Please, Jose Maria.
Thank you, Eduardo. Can we continue with the next slide, please? First, I would like to explain a bit the context of ATM digitalization. The airspace architecture study, produced in the SESAR context, envisages the use of the latest technologies and architectures in order to provide the required resilience and scalability to the ATM network, allowing a more flexible provision of ATM services. This flexibility will also allow a more efficient adaptability to the actual evolving needs, scaling up and down depending on the required service level at any moment in time. Latest technologies can help in order to achieve these objectives. First, virtualization and ultimately cloud-ready technology, so ATM services will be platform agnostic, providing flexibility to be deployed on cloud infrastructures, either private or hybrid. Secondly, standardization to implement the as-a-service business model. Service orientation and open architectures will foster agility to deliver new services and open ecosystems. And last but not least, cyber resilience. Business continuity must be adapted to the new context, where redundancy is not enough. ATM architectures must ensure geographically decoupled services and provide a comprehensive response to cybersecurity threats. Some of the most important benefits to be eventually achieved are here. To dynamically balance the ATM service levels depending on the actual demand, achieve cost and environmental efficiency, rationalizing the investments in infrastructure, and support the provision of new services and business model. And next slide, please. Here I will present a core architecture concept when we consider the virtualization of ATM systems. Geo-redundant virtualized data centers. This is based in geographically unconstrained virtual data centers, which are decoupled from the location and the number of ATC centers. The main features of these architectures are virtualization, providing optimal use of physical resources and reducing the environmental footprint, automation of deployment and configuration to reduce effort and time required, as well as human errors, optimizing operational and maintenance costs. Scalability by means of dynamic and flexible provisioning of physical resources, and HMI remoteness, which allows the provision of services to the end users from geographically remote data centers, ADSPs, minimizing the infrastructure and maintenance that will be required locally in ATC centers, the ATSUs. Can we continue with the next slides, please? The concept of service-oriented architecture is implemented by means of different layers, allowing a standardized and efficient and flexible strategy to provision and integrate applications and data systems. System deployment will be based on infrastructure as a service or platform as a service approach, decoupling ATM applications from the supporting infrastructure. The enterprise integration layer includes the components dealing with external interfaces. ATM information services will be provided using Swiss standards and ECAL format specifications. Next slide, please. This is a summary of the main technological enablers that will facilitate the transformation of ATM architectures and the initial steps that we are taking to support this evolution within a tech B3 context. First enable is cloud-ready capability. Our aim is to make the use of hybrid cloud infrastructures for tech systems, mainly to support non-operational missions. We have already initiated the journey with a proof of concept activity where we have successfully run an ATEC instance in Microsoft Azure Public Cloud. This capability will allow rationalization of the infrastructure for non-operational activities, such as training environments, ATC validation and evaluation sessions, or testing and development activities. We will be able to dynamically provision the infrastructure just when required, and release them after finishing the activities. Next enable is focused on the evolution of the technology stack. Web technologies will be adopted to facilitate service provision. We will take steps to break the traditional monolithic design of ATM systems by relying on microservices and event-driven architectures, where applications are deployed on containers that are dynamically orchestrated by the platform. This will allow scalability on demand, optimized for specific services. The last relevant enabler is related to the technology required for achieving the virtual center concept. First is the capability to provide remote user interfaces, decoupling ATM service provision from the geographical location of the ATC users. Then, standardization on the definition and provision of ATM services to facilitate the integration of different ATM actors. Can we continue with the next slide, please? And finally, a hint on cybersecurity, which in its widest definition must follow a comprehensive approach aiming to ensure confidentiality, integrity, and availability of information. Cybersecurity processes and controls have the objectives to provide protection, early detection, and eventually apply an appropriate response when security has been compromised. The different security aspects in the ATM context can be articulated in the following domains. In the governance area, security processes and activities are defined as part of the cybersecurity management plan. Within this area, the implementation of security requirements is evaluated and audited. Solutions deployment is aimed at building security architecture solutions and applications that detect and mitigate emerging threats. Training and awareness are focused on people, so they are able to prevent, detect, react, and respond to cyber attacks. And finally, the operation domain covers the assessment and management of vulnerabilities on the services in operation. Here we end this part of the presentation, so thank you.
Many thanks, Jose Maria. I would like now to introduce our next presentation on voice IP solutions. We will have two speakers to cover this topic, first from Indra point of view and then Naires. So our next speaker is Jose Alberto Delgado. Jose Alberto is principal architect for air traffic management, voice communication solutions at Indra. He is telecommunications engineer with over 20 years of experience in air traffic management systems, especially in voice communication control systems. And he has been involved in sales, business management, bids, product roadmap definition, and many more areas. So please, Jose Alberto.
Thank you. Thank you for your presentation, and good afternoon to everyone. With my presentation, I would like to share our view of what digitalization of ATM means in terms of voice communication and what benefit it brings. Next slide, please. Okay, first question, why IP voice? As you surely know, the voice communications are essential to the air traffic control. Let's say it's the main tool that the controller is using for the ATC control. And this has been traditionally quite rigid, with the use of analog protocols and point-to-point connectivity. However, this change the voice over IP, the IP voice changed everything, because we with the voice over IP, the voice streams are digitalized and change as data in the IP infrastructure. Moreover, with this digitalization and the flexibility that it brings, we can partner. I mean, the voice communications can partner closely with the automation systems. So this will not only partner in terms of the infrastructure, but also sharing all the functional evolutions. Next slide, please. Okay, some benefits that full IP voice switches brings to the air traffic management. Of course, there's let's say an unlimited and seamless scalability. We can add to our network all the voice switches, all the voice communication systems. Even as in the example, a countrywide and large network. In the left side, top left side, as you can see, another benefit is that all of them can be interconnected, which brings the massive interoperability between all the systems using, for example, a national IP network. And finally, with the other two, third benefit that it will bring this close interoperability and connectivity between the voice switches, IP voice switches, is that in case of any failure, in case of an event in some of the voice switches, the other centers may turn over and take control of that airspace. So the contingency scenarios can be solved in an easy way that it was not possible in the past. Next slide, please. Here in the following 2 or 3 slides, I will share with you some of the differences between traditional voice switches and the full IP voice switches. First one is, as you can see, the traditional switches use a central equipment, which is, let's say, it's the intelligence, is the brain of all the system, and it's providing and routing every communication inside the system. And let's say in the control positions and so, it's only a terminal position with no intelligence. However, the full IP switches, we have every component of the system. It's using its own means, its own intelligence to route and to manage their own communications. This means that in case that we have some failure in one of these components, it will not affect in any case the rest of the system. Going to the second, to the bottom part, as you can see, it's the traditional voice switches were, let's say, were quite complex with all these proprietary and wiring and protocols and central equipment, quite complex to deploy and to maintain, and also quite fixed, quite rigid. However, with the full IP voice switches, what we have is flexibility. We have these systems are fully software with a complete decouple of software and the hardware platform, which brings, I think, in nowadays in these pandemic situations that we are living, it's what we need to have this flexibility. Next slide, please. More benefits that I can show you. In the past, just to cover a voice stream, a voice path, there's a lot of conversions, a lot of exchanges, different means, different protocols, and all this brings a worse quality and bigger delays. However, with the full IP voice switches and the voice over IP, we have the audio digitalized from the source, let's say, from the control working position, or in the other side from the radio, with brings an end-to-end voice over IP communication from controller to radio natively. This also helps not only not to prevent any errors, conversions, and so, but also we can take advantage of the use of IP networks. For example, the wide area networks with high speed and high availability. And in the bottom part, we can see another benefit. With the traditional switches, all these proprietary protocols and hardware, which are, let's say, quite tight hardware and software, it's impossible to go, let's say, virtual. It's impossible to use cloud and virtual and virtualization in the same way that we have with our full IP voice switches, which are let's say cloud ready. We are doing some good solutions which are completely cloud. Next slide, please. Okay, I think this is my last slide. I want to show you our roadmap to the future, as it is saying in the slide. In the, let's say, in the close future, we have 3 examples of what we are working on. First one is to go fully integrated with the ATC position. Not only same hardware, not having a different panel, but being fully integrated, using the same graphical display as as the automation systems, having the voice service, the voice communications completely integrated into the tool for the controller using artificial intelligence, voice recognition, and so this is something that will help and simplify the task for the controllers. Second one in the middle is the UAV pilot communications. I think you all are aware that we are facing some issues and some we have to figure out how to let's say share the same airspace between UAV and regular flights. So this, I think, the main tool, as always, as I said at the beginning of my presentation, voice communications are essential. So voice communications between UAV pilots and controllers are essential, and I think we believe voice over IP will help to do it. And last but not least, remote digital towers and virtual center solution are good samples of the benefits that the digitalization of the ATM brings. And that's my last slide. Well, next slide. Okay, thank you. Thank you for your attention, and any question I'm here. Thank you.
Many thanks, Jose Alberto. Really interesting to know more about the Indra's activities and the roadmap to the future on digitalization of ATM voice communications. So our next speaker is Manuel García Martín. He will be presenting the voice IP deployment in Enaire. Manuel is the head of communications division at Enaire. He has more than 25 years of experience in CNS ATM project management. He's an active member in several international working groups relating to new communication systems, in Eurocontrol, accounts, SR deployment manager. So please, Manuel, the floor is yours.
Okay, thank you very much, Eduardo, for your nice and kind presentation. My intention with this presentation is to complement the previous one, talking about the benefits of the implementation of voice over IP, but looking at mainly giving an orientation or an NSP perspective. What has been the benefits that we have taken in Enaire implementing voice over IP? To comment that we were started more than 4 or 5 years ago about this project, and today we are making a photo about the current situation is really to that we have the full implementation, the full migration from the legacy telephony and radio services to voice over IP. And my idea with this presentation is to share the very high principles and what has been the lessons learned in order that people that could be thinking to define a strategy for migrating to voice over IP from the NSP perspective could be taken into account. Okay, maybe let's move to the next slide. Yes, also to complement the previous presentation and having in mind my NSP perspective, what are really the major benefits that we have seen regarding the voice over IP? Of course, the first thing is very clear to understand is that we are moving from the analog a legacy solution to a digital one. This means that automatically you are taking all the benefits of implementing digital technologies. But not only that, is that we can reduce a lot of intermediate black boxes that we have to use in our radio and telephony services for sending different signaling that now in voice over IP is fully integrated with the standards. Then we are reducing a lot of intermediate black boxes, increasing very clearly and automatically the quality of the service that is provided finally. Okay. Voice over IP allows something that for me is very, very important. Is the integration of the current ETC voice and data over our ETC networks. That is to say, instead of having point-to-point listed lines or point-to-point solutions that normally are very expensive, and where you are having a problem with this line, you are losing the service, and you have to reroute the traffic or to reuse another communication center, in this case, you can take all the power that the network, IP networks are giving to you in terms of resilience and reliability. Using different operators, different resilience solutions, you are able to increase dramatically the availability of these kind of services. Of course, in addition to this, or using also these networks, this gives a better scalability and flexibility to cope with the increase of our ATC communications. Just now, you need an additional telephony or radio service. You don't need to contract a new line and waiting and pay more money for that, but you can configure very directly and quickly over the network. Okay. Also, in addition to these pure technical matters, in most of our European countries, we are seeing that our telecom operators are discontinuing the current legacy analog services. That is to say, it's not only a question that the money that you are saving and really the increase of the flexibility that you need for these services. The question is that the legacy services really are discontinued. The more and more the telecom operators are not keeping these services provided in the corresponding portfolio, and we are obliged really to migrate to another technology. Okay, looking at the cost, because we are of course that our priority is to give the service, but we have not to rely to reduce the cost. To say that using this integration in the networks, we have increased the 1 by 10 the bandwidth that is dedicated for voice, and we have reduced the 50% of the cost. Okay, this is the real figures that we have experienced in an area in Spain implementing voice over IP. Increase up to 10 times more about the services in terms of including recording and some other contingency services that I'm going to explain now later. And at the end, also reducing 50% the cost associated with that. Okay. And finally, we are going to see during this presentation, voice over IP allows the implementation of some operational concepts that are not possible really with the current analog technology. As for example, the implementation of contingency, the possibility of sending different, the same service, the same radio or telephony service to different places in order to implement this contingency concept. This next slide, please. Then voice over IP solution in an area is based really on a progressive migration of the end system that are working with these voice services. I'm talking mainly about voice communication systems and radio equipment. But recognizing that this process is taking a long time, because, for example, in Spain, we have 5 control centers, more than 50 towers, more than 25 remote communication centers. To change all this infrastructure is going to take a long time, because also you have to respect the amortization times. Then, in order to accelerate the migration to voice over IP, also we were combining this strategy with the use of some specific converters, voice over IP gateways, based always in the EuroCAE standards, in the EuroCAE specifications. You know that EuroCAE in the working group 67 was specifying very clearly the standard that has been promoted by ICAO to be a global solution, a global specification for all the world. Okay, the idea with these gateways is that is to decouple the migration of the end systems, voice communication systems and radio equipment, to a native voice over IP solutions from the migration to voice over IP of these analog flows. You are installing this converter that normally, these gateways that normally are much cheaper and much easier to deploy quickly. In 1 to 2 years, you can perfectly deploy in your country, and these gateways are converting the analog interfaces, the analog services into voice over IP. You can use in order that you can deploy these services over your network. This gives to you from the very beginning practically all the flexibility and all the advantages of the voice over IP. You can remove the legacy and discontinued legacy analog services. You can reduce the cost. You can increase the availability thanks to the use of the network. and you are taking more time to change quietly the end systems from the legacy ones to voice over IP ones, when really you have the corresponding budget or when you are expecting the corresponding amortization times. Okay, please let's move to the next slide. Here you can see how at the bottom we have our legacy traditional point-to-point illicit line for the communication between two voice communication systems or between the voice communication system and radio equipment, and how you can implement very quickly these converters, these gateways, analog digital gateways, in order that you could take the benefit of using your network. In our case, is REDAN. REDAN is the name of our ETC IP network, for performing this migration to voice over IP very quickly. You can do this in 1 to 2 years, okay? And in a second and parallel line strip, you can migrate the voice communication system and radio equipments to native voice over IP. This is the approach that we were using in NIDE, and the approach that and strategy that I'm recommending to you in order to meet or to take the maximum of the voice over IP benefits as soon as possible. Please go to the next slide. Okay, voice over IP allows the implementation of what it is known as voice communication, virtual voice communication system concept. Just now we are moving from legacy solutions, hardware oriented, where you have one specific line that gives to you the corresponding radio service or telephony service. You are now moving to voice over IP, and you can use the network. Once that your system, voice over IP system, is connected to your IP network, you can send and you can receive any service from anywhere at any time. Then you have one frequency, one communication center. You can perfectly establish that one specific controller working position in one of the control centers will be making a connection with this radio equipment in order to use these frequencies. In parallel, it's possible that other voice communication system, even in other site, could have a voice over IP connection with the same radio. Then this frequency could be available in different sites at the same time. Okay, this gives to you the possibility to think about in the concept of a distributed voice communication system. Really, just now you don't need to have the hardware in each of the locations. You could be working with only pure controller working positions that are exchanging traffic with the radios in a native way, with no need of additional hardware locally in each of the places. The same applies to the recordings. Now you don't need to have the recorders locally and physically co-located with your voice communication system. Perfectly, you could send the traffic and to record in other recorders, or to have a mixed solution using local and remote recorders. In other words, voice over IP allows to you to implement a full distributed solution. Okay? Let's go to the next slide. Again, in order that you can take all the benefits of voice over IP, you need to support this over a very good and reliable network. For networks, for IP networks, voice over IP is the most stringent service to be provided. Not only in terms of delays, of keeping the delays and the packet loss parameters under control, is because you need to control the variation of this delay in the time, what it is non-digital. Then this gives to you, for the people that is responsible of the networks, the responsibility to design a specific solution for supporting these voice over IP services. It's very usual than taking into account that you can sharing the same physical network for different services, voice and data. It's very typical the use of the concept of the virtual private networks, VPNs, thanks to the MPLS technology that allows to you to create something, several logical networks over the same physical network. Then in this case, you can design a VPN dedicated for voice, where you have all the protections that is required for this kind of services, that you know that it is the most stringent one. As an example, in Spain, we have deployed this solution over a dual telco approach. We are using two different telecom operators, completely isolated between them, in order to assure that there are no single point of failure, and with the objective to achieve the 5 nines availability that is required for the radio service. Okay, I can tell you that we are operating this solution during the last 2-3 years, and we have not had any problem, any loss of connectivity at any place in Spain. And if we are talking about control centers, towers, and communication centers, we are talking about more than 100 nodes. Okay? We are having a very, very good experience with this approach, and with a much higher availability that we obtained previously with the analog licit lines. Okay? Please go ahead to next slide. And finally, to comment, because until now I have explained how voice over IP has been improving several parameters in comparison with legacy. But now I would like to explain or to talk about some concepts that really are not possible with the legacy analog voice. I think that these kind of concepts are only possible with the implementation of voice over IP. And it's a project that we are deploying in Spain about the contingency. We have 5 control centers. I'm representing in this slide several users that are working towers or communication centers that are working with the communications with the control center 1, and other users, other towers, other communication centers that are working with the control center 2. Okay, just today, previous to the voice over IP, for when you are using licit lines with analog technologies, the frequencies are in one specific control center because you have established specific licit lines. Then it's not possible to move these frequencies to other control centers or to other contingency centers, simply because the licit line provided by the telecom operator ends at this control center. But now that you're using networks, voice over IP over network, it's perfectly possible to send any traffic to any place. Then one project that we are having in progress is what we know intercontingency center. The idea is that each of these we have 5 control centers, but we have defined 2 of them, the major ones, Madrid and Barcelona, as the contingency for or to be used in the case of a contingency in the other 3 control centers. Then, for example, if in the Balearic Islands, we have a control center. If this is completely down, the idea is that Barcelona could take 100% of the control of the Balearic airspace. Please, next slide. This is represented like this. One control center is completely destroyed, and thanks to voice over IP, thanks to reconfiguration and the use of these IP networks, it's possible to send all this traffic, telephony, radio, and data, of course, to the second control center that goes on providing the service in the corresponding region. But now, in addition, it's giving service also to the airspace that was lost by the initial control center. Just now we are in this process. In fact, this month, between this month and next month, we are going to put into operation the first intercontingency procedure between Palma de Mallorca, Balearic Island, and Barcelona. And at the end of this year, our idea is that this contingency solution could be fully deployed in Spain, involving the 2 major control centers, Madrid and Barcelona. This could be practically impossible to perform with legacy technologies. Then this is a very clear new operational concept that is possible thanks to the new voice over IP technology. Okay. Next slide, please. And finally, to comment that in this contingency strategy, I was explaining the concept of the contingency of the site. But now you can ask me, Manuel, you are concentrated a lot of services over the network, data and voice, even with the dual telco and the different VPNs. But what is happening now if the network, by any reason, is down in one specific area? The idea here also is to be able to manage what we are knowing, or we are calling a contingency network. That is the name in our case in Recon. In this case, of course, the idea is that this Recon or this contingency network is not providing the full 100% of the operational services, but the critical ones, or the services that has been considered critical ones, has been also protected by this contingency network. That you need to implement this contingency philosophy in different levels: the level of the site network, and finally at the level of the service is where, for example, you are maintaining your own transmission means. For example, with some microwaves, you have a very important communication center that is close to your control center in the mountain, and you could have a direct microwave. Then, of course, you can keep it as the last resort. Okay. Next slide, please. Okay, and that's all. Thank you very much for your attendance, and I will be very happy to answer your question at the end of the session. Thank you.
Many thanks, Manuel, for a very interesting and comprehensive presentation. So please send your questions to Manuel. The next presentation is on digital NOTAM and SWIM, another very interesting topic. Our first speaker will be Dr. Svetan Penev. So he's the head of product management and SWIM product manager at Indra Avitech. Svetan holds a master's degree in mathematics with focus on computer science and a doctorate of natural science with focus on aviation data and computer science. He has wide experience in product management and research in the ATM field. Please, Svetan, the floor is yours.
Thanks, Eduardo, for the nice words and the introduction. Good morning, good afternoon, good evening, wherever you are around the world. Thanks for joining this webinar. So I just wanted to give you a few words. For those of you who probably don't know us, we are a 100% subsidiary of Indra Sistemas. So Indra Avitech has its headquarters in Germany, but has offices also on a number of other places, in particular also a big office in Bratislava. And we are focusing mainly on the management of aeronautical information. We're building systems for that in various levels and various use cases. But the focus of today's presentation is on system-wide information management and digital NOTAM. I would like to give you a short update on where we stand today in terms of SWIM. What are the, I would say, latest developments, where we stand in terms of deployment, what is the link here with digital NOTAM, and then Michel is going to give you a bit more details, my colleague, on digital NOTAM, and then lastly I would like to put digital NOTAM and SWIM in the context of digitalization, which is the topic of this whole webinar. Next slide, please. So I assume that a lot of you have seen this, but I keep repeating this because I think this is really the foundation of SWIM. The definition that came out of ICAO states that SWIM consists of standards, infrastructure, and governance enabling the management of ATM-related information and exchange between qualified parties by interoperable services. Now, this is really the core about what system-wide information management is, but I wanted to point your attention also to the so-called global interoperability framework that comes from the SWIM manual, at least the one that is published there from ICAO. And to point your attention in the middle of the picture, you see that the SWIM scope is actually in the three layers in the middle, covering the SWIM infrastructure, information exchange models, and information exchange services on the top. This, coupled with the governance of these three layers, is what we're talking about when we're talking about SWIM. Of course, SWIM without the underlying network infrastructure, like IP infrastructure, is not possible. This is a prerequisite, of course, in order to be able to move to the layers above. And last but not least, you can see on the very top layer, we have SWIM-enabled applications, which is usually what you as users from the ATM domain will be seeing and using on a daily basis. That should, of course, hide all the technological details that we're dealing with in the layers below. So just to keep this in mind, this is still valid and it's very important for understanding and putting, I would say, SWIM in the right position. But where do we stand today in terms of standardizations, regulations, and deployment? Next slide, please. I will give you a look and reminder probably on the situation in Europe. We've had until recently the so-called Pilot Common Project Regulation, which was recently reviewed by the Common Project 1 regulation just a few months ago. But they all have something in common, namely the so-called ATM functionality number 5, which focuses on SWIM. The idea here is that we have 6 subdomains, and in particular here I would like to point your attention to the aeronautical information exchange part, which covers, among other topics here, of course, the exchange of digital NOTAM for a number of the most important airports in Europe. They are listed in the Common Project 1 regulation, and this applies, of course, all of them. As you can see, the scope of the regulation is, of course, the European ATM network, and the deployment, deadlines. For instance, here you have the first part, namely the common infrastructure components that are expected to be deployed by the end of 2024, and all the rest by the end of 2025. So a lot is moving, and there are, of course, already a number of examples of capabilities that are already implemented around and partially even deployed. So keeping that in mind, I wanted to point your attention now to digital NOTAM and one important project that is still ongoing and very relevant in this respect. Next slide, please. Eurocontrol recently launched a call for tender for a project called the Airport Data Toolkit, funded by the European Commission. In this case, we're talking about a project that is focusing on the development of a prototype digital NOTAM application for the origination of digital NOTAM using airport mapping data as the basis for that digital information, and then sharing that digital NOTAM event information through SWIM standards. Why is this very relevant? Because this directly can be linked to the regulation that I mentioned before. This is, just an example of how, airports and states can provide their respective implementations for digital NOTAM. As you can see on the right side, there is an example of what we did from Avitec in our digital NOTAM application, so that users are capable of doing their job and creating digital NOTAMs in a fairly seamless manner, supported by the system, and at the same time, not only digital NOTAMs, but the system also automatically creates, for instance, the conventional NOTAM, which is of course still the main means to share dynamic information. The whole solution is running in the cloud, and it's focused, of course, around data. It's based on a number of standards, both from an airport mapping data point of view. So we have here RTC EUROCAE, but also XMS standards for the encoding of information, and then SWIM standards for the exchange of that information. The whole organization of the project, the role of Eurocontrol, Avitec, and all the other partners, you can have a look at the link below. This is the official page of the project. It is public information, so you can have a look and you'll get the presentation, and of course also the video will be available afterwards for you to go into details or perhaps ask some questions at the end. Next slide, please. So where do we stand in terms of SWIM in our company? So Indra Avitec is developing its own SWIM product. It is focusing mainly on providing implementation for the Eurocontrol SWIM technical infrastructure yellow profile provisions and requirements there. And we have already a portfolio of roughly 30 and actually even more services already implemented. Some of them actually predate even the first definitions of SWIM, because we had customers that were really interested in those technologies even at some years ago. With that, I want to say that a lot of it is considered mature technology that has been proven in the field for a number of years. But I'd like to point your attention here to two specific services that, from an aeronautical point of view, are very important in terms of sharing aeronautical information, but also in meteorology as well. And the first one is namely the Web Feature Service specification, which is both an ISO and OGC standard. Our implementation is at the same time compliant to the OGC provisions. We are following the test suite that OGC is providing, and we're actually one of the reference implementations. Just to point out, there are only 3 out there, so we have one of them, and we're very proud that we are supporting this initiative because from our point of view, standardization is key to interoperability, and this is of course in the in the veins, if you wish, is the foundation as well in SWIM. But at the same time, a lot of the standards have also room for interpretation here and there, and we believe that really only through compliance testing you can really absolutely be sure that you can have interoperable solutions. The implementation supports a number of the important syntaxes, including here AXM51, IWXXM, but in general also any GML application schema. It follows completely the requirements in terms of request-reply type of communication, but it also provides various extensions to that specification, covering also the possibility to use publish subscribe type of communication for exchanging and immediate notification of particular changes. Last but not least, the so-called WFSTE, or Web Feature Service Temporality Extension, which is a specific specification again from OGC here in this case, that covers really some particular details and complexities of the temporality model from AXM, so that really meaningful queries can be executed and only the really relevant information can be extracted based on those. Next slide, please. So of course, there's a lot of technology and a lot of details, technical details when we're talking about SWIM. I just wanted to give you again a flashback, if you wish, to some years ago when there was a demonstration that was done at the SWIM Global demo. The point here is actually that a SWIM-enabled application like this belongs to the topmost layer. So usually you as users are going to be seeing applications like this to do your job. And it's essentially the job of the industry to work on the actual technical details, all the nitty-gritty details that need to be in place and fixed so that this kind of application can provide seamless access to that information. Provided here also the link from that time. There was a recording, so if you had the chance or maybe missed it last time, you can still have a look. Next slide, please. Now, we talked about a bit of services and all the nice things that they bring and how you can share information, but you can surely imagine that there are a number of providers of services out there, and putting all these services together, it will become pretty messy, I would think, to enable to find information. So in order to find what you're really looking for in terms of services, the concept is that there's going to be a SWIM registry that is going to host all the metadata that those services need, so that interested consumers of those services can search in that registry, discover the relevant services they would like to connect to, and then implement based on the provided technical details and establish the connectivity. On the other hand, providers, vendors of software that provide these kind of services and implement them, once they implement it, they can provide all the metadata that is needed for them in the registry, so that they can be discovered by the users. And by users in this case, most of the time it's consumers that actually get information, but of course these can be providers of information or even both at the same time. So this really depends on the use case and on the service that is provided. But here key is the concept that we have a registry that provides the capability to discover and at the same time for the providers to publish that information. And there is one example, at least, that I wanted to bring up here on the next slide, please. We have in Europe, at least, the Eurocontrol SWIM registry. I've provided here a link in the picture for you to check it out in case you don't know that. You can register, it's free to access it. I have filtered here the results. There are many more registered in the registry, so you can have a look at what is available already there. And I'm sure that over time, the number of services that will be provided will grow, and it will become, I would say, more and more important to have a look in the registry and see what's available already out there. Next slide, please. So to sum up, I wanted to give you a few takeaways before I hand over to Michael and on the topic of digital NOTAM. A few takeaways that, from my point of view, are very important in the context of SWIM. Quality assured data is a prerequisite for SWIM. So you cannot expect that SWIM is going to improve the quality of your data. You cannot expect that SWIM, you cannot equate SWIM to improved quality, improved, quality of the data in terms of, merging it from different sources or any of these kind of improvements. SWIM is there for interoperability. So you need to have a solid foundation, you need to have your quality assured data, and then SWIM is going to enable the interoperable exchange of that information. So this is really, really key here. Of course, no one stops you or the industry of providing, I would say, advanced services to improve the quality of data by merging, for instance, pieces of information from different sources. But the main point of SWIM is interoperability. Then the other thing that I wanted to point your attention to is the interdependencies between the different domains. Now, there are a number of systems deployed around the world that focus on either AIM or MET or flight, but there is still, to a large extent, a lot of isolation without considering the interdependencies between those. So, an airdrome is an airdrome, but it is used differently in a different context, and we need to make sure that there is, I would say, referential integrity between those, and we're talking about the same things. So this is something very important that I believe both, the whole ATM industry needs to make sure that we're on the same page here. Last but not least, sharing data in a SWIM compliant manner, from my point of view, is the first step to digitalization. And I'm going to come back to this on the very last slide at the end of this webinar. But from my point of view, sharing information is the first step into reaping benefits, and not for only one organization. I want to stress here all, because the benefits will be for all of us and not for only one particular user of the system. So thank you for your attention.
Many thanks, Svetan, a very insightful presentation. So the second part of this presentation will be made by Michal Karlek. So Michal is software engineer working over 20 years in development of AIM systems on different positions, from software developer, architect, trainer, through business analyst up to product manager. He is currently responsible for collecting requirements and definition of new releases for Indra Abitec AIM products. Please, Michal.
Thank you very much, Eduardo. Good morning, good afternoon to everyone, also from sunny Slovakia. In the next few minutes, I will try to introduce the digital NOTAM concept and what Indra Abitec is providing in this area. But let's start with the question why we need digital NOTAM. I'm sure all of you here today know what NOTAM is and how important it is for the safety of daily air traffic operations. But due to the age of the technology which we are using, and some selected already in the middle of the last century, and the growth of the number of the NOTAM issued every year, we are approaching the limits of what the current system current NOTAM system can provide. So digital NOTAM is an evolution of the current NOTAM system, which should help us overcome these limits. The biggest issue with the NOTAM system is that many of them, some of you already have seen these funny images on the screen, where the pilots are presenting their briefing cases with dozens of pages of the NOTAM they are getting before the flights, and they are expected to go through them, read them, and understand their importance for their flight. Definitely not all the NOTAMs included are relevant. Some of the NOTAMs which are there should be already cancelled, and some of the NOTAMs included shouldn't be published as a NOTAM at all. Digital NOTAM will not really reduce the number of the issued NOTAM, but it will help you to select only those NOTAM which are really relevant for particular flight or particular case. Text NOTAMs are also too hard to read and to comprehend, so they are written in all caps, so it's essentially like shouting at you when you are reading them. They overuse abbreviations, which are not always common abbreviations, and same type of events are described different or coded differently when they are entered or breaking by different NOTAM operators. Here, digital NOTAM will not only provide uniformity, that same events are really coded in the same way, but it also brings opportunity to present the NOTAM information in different ways for different use cases and even for different types of users. You will be able to present them visually as a different text representation, etc. Furthermore, due to text nature of ITME, the current text NOTAM is not really always fully cannot be really fully validated by the automatically by the system. So manual validation is required to validate if the NOTAM is correct. Digital NOTAM will allow this fully automatic validation because the information will be coded as a structured data. And as well, it will allow fully interpretability by the system. So software systems will understand what the NOTAM is saying and will be able to act accordingly based on the information which is provided in the NOTAM. So, for example, you will be able to generate and visualize specific warnings. You will be able to control your ground lights just based on the information which is included in the digital NOTAM. So what it is, digital NOTAM? Next slide, please. So this is from the AIS2M roadmap, and digital NOTAM is essentially a small data set which contains practically same information as a current NOTAM. So it's the same information, but it's coded in a way that can be automatically and fully interpreted by the system as well as humans. In most cases, digital NOTAM references existing infrastructure. So therefore, as a prerequisite, before you can even start to issue digital NOTAM, you will need to have also your baseline data in digital form. And also what you will need is to have an exchange in place where we are coming back to the same requirements for distribution of the digital data between the users. If you will not have this, you will not be able to communicate the digital NOTAM, and if your users will not have the baseline data available, they will not be able to interpret the meaning of the digital NOTAM. And as many of the NOTAM are related to the airport infrastructure, also the airport mapping data need to be available in the digital form. Airport mapping databases, as defined by RTCA EuroK, cover a large number of different types of airport features and rules how they should be collected. But it is important to realize that not all of these features are required really by the digital NOTAM. Also, the quality of the data which needs to be collected for the purposes of digital NOTAM doesn't have to be the highest accuracy and resolution as required for some other applications using AMDB data. So this is just to encourage you that you don't need to have the complete AMDB data sets to be able to start with the digital NOTAM production. Next slide, please. And this one is extremely important for the success of implementation of the digital NOTAM and the exchange of the digital NOTAM. So to really be successful, we all need to follow same digital NOTAM specification. If we will not have the common digital NOTAM specification, we will not understand each other, and we will not be able to interpret NOTAMs which are received by systems following different specifications. Currently, there is no ICAO digital NOTAM specification, or there is no specification endorsed by ICAO. Anyhow, there is a specification which is created by the AI exam community led by Eurocontrol that is working on defining specification for a different type of NOTAM events. Currently, there is already they already defined the digital NOTAM specification for around 15 events, and they are working on additional events. And I'm sure, as this is a community work, if there is any one of you interested in participating in this event, you are welcome to join. So this specification is very important, and it contains several aspects. It contains description when certain scenario can be used. It contains what data should be collected to represent the event. it describes the assumption of what baseline data need to be available to create the digital NOTAM and interpret the digital NOTAM. And it also contains validation rules to make sure that the data which are provided are correct and complete for specific type of digital NOTAM event. And at the end, it also contains coding rules, how this information should be coded as an AIXM message. And as there will be for quite some time, we will have to live in the world where we have a digital NOTAM and a text NOTAM in parallel. It also contains rules how to generate the text NOTAM out of the digital NOTAM. Next slide, please. So now a bit about what Indra Avitek is doing in regard of digital NOTAM. So we developed something we call digital NOTAM portal. It's a web-based interface which allows different types of users to access the system. For the NOTAM originators, it provides interfaces to select visually affected objects and create a dedicated NOTAM for these objects based on this event specification. So you are presented with the tailored screens which contain exactly the fields and guide you to collect all the information which is necessary for specific NOTAM type. There are also business rules which are validating if all the information is provided. There is a built-in workflow which guides you through the process and ensures that the information is properly validated and approved before it's published. And at the end, we generate the digital NOTAM and the ICAO text NOTAM out of the information provided by the NOTAM originator. For the NOTAM users, we provide briefing facilities so the users can see in different forms NOTAM valid for a selected period of time. They can see visually on the map or see them as a text NOTAMs or as a digital NOTAMs as a data in data format. And we also provide interfaces for third-party systems, but more about this on the next slide. So please, next slide. As we have two formats in which the NOTAM is distributed, there are also different interfaces to distribute them. So first, the digital NOTAM is distributed through the built-in SWIM interfaces. We can provide the digital NOTAM in a form of AIXM message through the WFSTE, or we can provide it in a graphical format through the WMS, which is web mapping service defined by OGC. Regarding the text NOTAM, to distribute the text NOTAM, it needs to be communicated through the ICAO NOTAM system. It can be either other NOTAM system, or it can be also third-party system or your current NOTAM system. The only prerequisite is that the NOTAM system provides interfaces for receiving NOTAM proposals, which are then distributed further through the NOTAM system. Next slide, please. So what we also provide in our case, that the digital NOTAM module can be deployed, integrated with other modules of our AM solution. So the users are then provided with a unified management of all different types of information, not only temporal, but also permanent information, AMDB, aeronautical data, terrain and obstacles, following the same workflow, same procedures, and using same tools. This data then can be further utilized to generate different types of products, publications, data sets, charts, following the ICAO standards, but also customized to specific user needs. We also provide different ways how this information can be distributed. So it can be distributed through the built-in portal interfaces, or it can be distributed through the provided system-to-system interfaces, or through the SWIM. Next slide, please. And we have even more. So, but I will not go into detail. So in the portfolio, we have additional products and solutions and services. But there is no time today for going into detail. So do not hesitate to contact us if you are interested, or visit our webpage if you are interested in more information. And with this slide, I'm hand the presenter role back to Cvetan to wrap up our session.
Thank you, Michael. Thank you, everyone, for your attention so far. So, in this very last slide, I wanted to bring up the topic of disambiguation between a lot of digitalization that we have heard here, and I'm sure that you have listened about it, also a number of other webinars. So I wanted to put this here on one slide, following what Gartner is saying. So digitization is the process of changing from analog to digital form, and digitalization is the use of digital technologies to change a business model and provide new revenue and value-producing opportunities. Now, of course, we are referring mostly to the second definition. We're talking about digitalization and digital transformation, and I wanted to put that also into context of what we have been presenting here in terms of AAM, digital NOTAM, and SWIM. So I see the transition from AIS to AIM, so moving from paper-based products to digital products, quality-assured products with systems that ensure the quality of the data that you're producing, to be the really foundation, something that you really need to have there to be able to produce that digital information. So that's what covers, from my point of view, the digitization, at least in this domain. And then we have SWIM on top of that, which from my point of view is then bringing it as the foundation of the digitalization, because with SWIM you get the information available in an interoperable manner there. And that's where I would like to challenge you as well and ask a question to you. How do you see your business change and your operations change with this information becoming ubiquitous all over the place, not only in the AIM and AIS domain, but also in other domains? And with this, I would like to thank everyone for your attention, and that's it from our side. Eduardo, yeah.
Yes, I'm here with you. Many thanks to both of you. Now it's time that we move to the Q&A session, and I have to apologize, but we don't have much time. We have roughly 10 minutes, so I think we will only be able to answer 2 or 3 questions from the audience. I have seen many of them. So in the next slide, actually, you are going to see the contact information of all the speakers. So I definitely encourage you to contact them directly. If especially we haven't had time to answer your question, please send your questions to the speakers directly after the webinar. So the first question is about the first session on presentation on integrating digital and remote tower systems. There were a couple of interesting questions, mainly for Torbjörn, but please, David, feel free to intervene, about how the control is responding to the changes and integration of the systems, and also about the external stakeholders. How did you convince all the airports that they have more similarities than differences? Could you elaborate about these points?
Yes. If we talk about the acceptance of the new systems and the new technology, generally that's very well received, which is also demonstrated in our validation exercises, like the passive shadow mode that we carry out, where we shadow the airport operation from the center, and also when we go into the advanced shadow mode. An important factor is also to take into account it's not just about acceptance of the technology, but it's also for many individuals a change process, and there the approach might be more individual depending on their situation. I think also in terms of embracing this new technology, we also see a kind of generation gap where we see now a new generation of people coming into the industry, and they actually seek to come to the remote tower center because they wish to work there. It has a degree of attractiveness in it. When the last question was about the dialogue with the airport customers, as I understood, and. Yep. we are in a lucky situation that we have one airport owner as our customer for these airports that we are introducing the remote tower services to. So we have, in our case, a centralized dialogue also with the airport owner. But of course, that drills down to each and every individual airport manager, and finally into each and every airport ground crew working there. But we have worked a lot with actually them both provide arguments and evidence, and also in practice demonstrating that the difference in the way we provide the service and the difference in the way that we interact with the airport ground crews from day to day is actually not very dramatic. Of course, it's a psychological and cultural thing that we are no longer on the site. We don't meet them over a cup of coffee, but that has not been a very big problem in our case, I would say.
Okay, many thanks. Next question is I think for Jose Alberto Delgado. Like, can you confirm the IP voice communication covers all flight phases and routes and approach?
Sorry, say again.
It's just if you can confirm that about the IP voice communication cover all flight phases and routes and approach.
Yeah, all of them.
Okay, then maybe a question a bit more specific for Jose Maria Caro about what is the current situation of the digitalization process in the ITEC context.
Okay, well, in the current version of ITEC, which is V2, well, we are currently defining V3 version, which is now called OneSky. But in the V2 version, there are already some capabilities in place with regards to the virtualization in the data center context. So the system is able to be deployed in a data center context, even distributed among 2 different physical sites. And well, we are also bringing the capability to support remote display units that are able to separate the display and the processing in different geographical locations using web or X11. And also we have been working in supporting a standard use of some platform services such as AAA, DNS, and NTP, and enhancing the automation of the deployment using COTS tools such as Ansible and Puppet.
Okay, as we're running out of time, I have a last question to all the speakers. Let's see who wants to pick it up. It's very generic. It's when we think about this future digital sky, can you just indicate what are our main challenges? What is in our way? It's about the change management, is regulatory framework. Do you feel that we need more technology research or the validation of new technology? Is anyone that would like to pick this question? Raise your hand. What would you identify like this is the main challenge?
Maybe I can give a try, and maybe my colleagues can complement. So from my point of view, I believe the human factor will be the biggest challenge, because okay, maybe I'm a bit distorted in my view because I have more a technical background, so I don't fear technology, and I think we have a very good grip on technology, and we're handling this and providing systems for a number of years. So technology and safety is something that we combine together, and this is, I would say, in our blood. But I think that technology is changing so quickly that we as humans perhaps are a bit lagging behind, and we need to take care about the human factor a bit more. But this is just my
I would in fact support that, because I think it's important to bear in mind that when we introduce technology, it provides a lot of opportunities to improve, to make it more effective and all of that. But still, any piece of technology comes with some limitations, and which we need to take into account. So the human factor is incredibly important, and taking that into account when implementing it.
Anyone else would like to quickly? If not, I think I just would like to close this webinar session by thanking all the speakers so much, and thanks to the audience for listening. Just from my side, my closing remarks, I just would like to highlight that this, again, to the reduced liquidity of the sector makes collaboration and the need to align our future investment more important than ever. That calls for sensible prioritization between stakeholders across the entire aviation value chain. It is only by working together that we will achieve a truly digital sky, and be able to deliver a system that is more scalable, economically sustainable, environmentally efficient, and resilient in the long run. So thank you very much again for joining us, and see you next time. All the best. Take care.
Thanks, Eduardo. And thank you to all our speakers today. And thank you everyone for attending today's webinar. Once you leave today's webinar, you will receive a survey, and would appreciate if you can complete that survey and provide your feedback. So on behalf of Avinor, Kanzo, Inare, and Indra, thank you for joining us today, and enjoy the rest of your day.